Hello students, how are you? Welcome to my YouTube channel. Today we are going to talk about the Gauss's law. So what is the Gauss's law and how we can define it? In this lecture we are going to clear this thing. Okay. So let me start with an example. I will take a shape which is a sphere. Okay, let me take a sphere. This is a sphere, okay? And let's say this sphere has a charge q plus enclosed in it. Okay, so what will happen, the electric field lines will move outward from this charge, okay, in this way, in this way, and in this way. Okay, so this is our example. Okay, so what the Gauss's law explains, the Gauss's law basically explains that the charge enclosed by any body is equal to the electric flux passing through it. Okay, so basically the Gauss's law says that if we have a body, okay, that is enclosed by a charge, okay, that's it is q plus, so the electric flux passing through that body will be equal to what, will be equal to the charge enclosed by that body. Okay, let us prove it. Okay, in the previous example, the previous topic, basically in the last lecture, what we studied that the electric flux is equal to what, is equal to ea cos of theta. Okay, ea cos of theta, where theta was the angle between electric field intensity and the vector of surface area. Okay, so let me zoom here. If I zoom here and let us focus here, okay, what we will do, we are going to focus here in this body. Okay, what I am going to do now, I will draw this body again. So this is our surface like this. Okay, and what is happening, a electric field line is passing through it. What is happening, a electric field line is basically passing through it. Okay, so if we draw the surface area vector, what will the surface area vector, it will be outward and perpendicular to this surface. So let me draw it. It will be like this. Okay, like this. So this is our area vector, and what is this, this is our electric field line. So what is the angle between them, we can see that both are parallel, so the angle between them will be 0 degree. What will be the angle, the angle between them will be 0 degree, and if I put 0 here, cos of 0 will be equal to 1, and our electric flux, will be equal to ea in this case. Okay, if we talk about the sphere, what will happen, our electric flux will be equal to E into A. Okay, so further elaborating, let me put the value of the electric field intensity here. As we know that the formula of electric field intensity is equal to K into Q over R square, where R is the radius, Q is the charge, and K is the constant. Okay, so this is the electric field, and it is going to multiply with what, it is going to multiply with the area. So this is a sphere, so we all know that the area of the sphere is equal to 4 pi r square. So this is the what, this is the area of this sphere. So let me put here, I will put here 4 pi into r square. So what will happen, the r square will cut with this r square. Okay, so now what we will do, we will put the value of k here. So our electric flux will become, and we know that the k is equal to 1 over 4 pi epsilon naught. So the value will become 1 4 pi epsilon naught, r has been cancelled, into q, and we all know that there 4 pi has left. Okay, so 4 pi here. So further what will happen, this 4 pi will cut with this 4 pi, and what we left, we will be left with electric flux is equal to nothing but the charge enclosed by that body over what, over epsilon naught. And what is this epsilon naught, it is also a constant value, it is also a constant value, and it is equal to 8.85 10 raised to power minus 12. Okay, it is relative permittivity constant of free space. Okay, okay, after that I am going to put another example. So let's say what is happening, I have a body here. Okay, let me again draw it. have a body here, it is a sphere again, okay, and I have another sphere here, okay, it is like this, okay. And what is happening, I have a charge q plus here. So what is happening, this charge will emit electric field lines outward, okay. So this green body is my A1 body, okay, and this purple body is my body A2. So the question arises, what is the electric flux passing through A1? Okay, first we will take the A1. So what is the electric flux passing through A1? So if we consider this shape, we'll come to know that this the A is the shape A1 sphere, and how much charge it is enclosing, it is enclosing q charge, okay, which is plus charge, okay. So what will be the electric flux in this case, it will be equal to q over epsilon naught. So it is the electric flux enclosed by this body A1. So now considering our body A2, so what is the flux that is passing through A2 body? So if we focus on this body, we can see that this is our body, okay, it's a sphere, good, nice, okay. So what is the charge enclosed by this body is 0, okay. So the charge enclosed by this body is 0. So let me put here electric flux is equal to q over epsilon naught. Because the charge is 0, so what will happen, there will be no flux passing through this body, okay. So in this case the flux passing through this body will be equal to 0. So it was the basic explanation and easy, so one of the most easy explanation that you can find here in the YouTube is here, that the Gauss's law is nothing but explains that the electric flux passing through a body is equal to the charge enclosed by that particular body. Just simple, okay. After that we have used the derivation, we have put the value, after putting the value we have proved that, okay. And this was the example here which will help you to understand this law more precisely, okay. So thank you very much, it was all about today's lecture. Kindly subscribe my channel and follow me on the Instagram.